Hello everyone and welcome to the Power Triangle series. In my opinion, the Power Triangle is the absolute most important triangle and we could get a lot of lessons learned via the Power Triangle. Before we start, this is just a high level view of my experience, current role and previous roles. Here is the Power Triangle. On a very high level, there are four things that we look for in the Power Triangle. Horizontal line, that's the real power. The vertical line, that's the reactive power. The apparent power, and the power factor. The real power measured in watt and megawatt in the utility scale. Reactive power, we measure it in MVAR, and the apparent power in MVA. And the cos of the angle is known as the power factor. Let's take a different view of the power triangle. The horizontal line in megawatt, notice I put negative dollars next to it. That's pretty much what you pay the utility at the end of every month for your total megawatt usage for every hour, every equipment for 30 days or so on a monthly basis. The reactive power is the most, I would say, ignored free power for residential customers and many commercial customers. They utilize reactive power on a regular basis, however, they do not pay for it. And then what's interesting about the MVA, pretty much that's the bottom line, or that's the capacity of the circuit, the substation, transmission line, whatever asset you're looking at. So one power you pay for your usage. One power is very critical almost for every equipment that you utilize, yet you don't pay for it. And then, the other power, which is the apparent power, that's the overall kind of the capacity of the system that you're looking at. So a lot of people talk about the reactive power as useless power, they compare it to the beer foam and stuff like that. I'm going to have a different video to talk about it, but for now, pretty much a lot of customers, commercial and residential, they don't really think about the apparent power. From their perspective, the real power is how much they pay for. The reactive power, for most of them, as I noticed, I mentioned residential and small commercial, they don't pay for it. And of course, the main goal is to reduce the total amount of money they pay on a monthly basis. Some or a lot of utilities, they started charging the very large commercial and industrial customer for their reactive power usage, either if the power factor drops below a certain level, let's say 90% or 85%, they will either get hit with a penalty or they are charged for their active power usage. Again, reactive power is very, very critical for the livelihood of the grid, and especially nowadays as you keep hearing about more and more fossil fuel power plants shutting down, that becomes an issue not just from a real power dispatch but also from a reactive power dispatch. What's really interesting is when you look from a perspective of solar or just any kind of renewable customer, notice now a couple of things. It's no longer a triangle, it's three different pieces, and it's all about the horizontal line. And notice the sign now, it's a positive dollar instead of a negative dollar. From a solar perspective, let's say it's a solar farm or a commercial solar, they basically, the customer or developers, they earn revenue, they make money when they generate real power, and their goal is to be at 100% unity power factor, so the cos of the angle is 1, which basically makes the triangle a straight line. So again, from a utility perspective, we need to look at the real reactive power, and like I mentioned before, apparent power is very, very critical. That's kind of the bottom line or the system capacity. However, from a developer perspective, they would prefer to be on a horizontal line, so their whole triangle is nothing but a straight line at unity power factor. However, as we're going to see in the future in one of the other videos, that you need to have a balance pretty much. So some customers or some utilities, they force all the solar developers to be at a certain power factor pretty much all the time, usually between plus minus 90%. So the desire for having a straight line, I guess it's not going to really be, I would say, it's not really applicable for the utility system, and you can always be in the power triangle. So again, it's a power straight line versus a power triangle, and in most cases the power triangle kind of wins. And depending on the utility, some utilities that suffers from a low voltage, they require the solar sites to supply reactive power to boost the voltage. Some utilities that suffer from high voltage, they would require the solar developers to be at a negative power factor to absorb reactive power. But the point here is that the power triangle kind of plays a big role whether you are talking about renewables, as a case like here, or just in general. And again, if you are just, at your home, all you think about is the power. If you're a commercial building or a business, especially the large ones, you have to pay close attention to the real and reactive power. And in the future, as we shut down more and more fossil fuel generation like coal, power plant, and so forth, more focus will be given to the vertical line. And if you want to understand reactive power is for the system, take a look at the 2003 East Coast blackout, where 50 million people lost power, and a big part of it is deficiency in the reactive power. So again, reactive power is the glue that holds the system together. It maintains proper voltage. So I hope you kind of provided a very high level introduction to the importance of the power triangle and the difference between a view from a utility and a view from a customer perspective.